All right, so let's get started. And this is a session on the first introduction to the concepts of Java. And as we have seen the overall course layout yesterday, we will first discuss with core concepts of Java, in which we will discuss the concepts of object-oriented programming language, strategies, and then we will understand the core syntax and semantics of Java language. It will discuss primarily what are the rules for doing something in Java, do's and don'ts. Okay, and this will be the core. This will be the basic for your overall career in Java. Understanding this will be pretty much important because without this, you will not be able to understand the future concepts. All right, and that's where it is kind of important. So let's get started. This is the contents what we already discussed. Yeah. So I will directly come. I'll not talk about this object-oriented programming strategy immediately because initially for a couple of sessions we will have the non-object-oriented programming model discussed with respect to Java, and once we are coming into objects and classes and all, then we will have a deeper understanding of these discussions. All right. So what is Java? Why people tend to use Java? Because there were languages like C, C++ existing for more than 2 decades. Then came Java late in 90s. Then people started adopting Java. So it has some good features. Okay, Java programming language provides good features which were not ideally available in programming languages like C or C++. And among them, the primary or important features what you can see was the architecture neutrality or platform independence nature of Java, which was kind of the feature which made Java very popular. And this is the most important feature if you go back in the languages which were prior to Java. All right. So what is platform independence? Platform independence means that the code written using Java can be uh, can be runnable on any machine without bothering the considerations of platform, the operating system, the hardware, the microprocessor or bit size of the architecture and all. So without bothering about that architecture, Java code is highly platform independent. Okay, that was the star feature. Apart from that, it was object oriented in nature, so which made programming easy. When compared to procedure oriented approach, object oriented approach provides you more easiness towards understanding or translating real world problems. Okay, so in real world you have some objects, and that's what you do in your program. You translate those real world entities to objects, and that makes you designing big applications and huge enterprise applications. You can design them easily. All right, so that is the another feature object oriented programming model which was followed in Java. And then the language Java is simple because it has kind of borrowed the syntax um, which was designed or coined by C or C++. So the syntax of C and C++ was used in Java, which made people accept Java easy, right? And that's why we have this feature called as simple. Java seems to be simple for people who have done programming using C and C++. So this syntax includes things like curly braces will have a block, and one statement is terminated by a semicolon, and variable declaration and initialization, things of that sort. All those things are similar in Java as well. All right. So this was one of the important again features. And Java applications are kind of portable. They are portable in nature because if you remember applications, if you have some idea on programming language like C, that is where you had different sizes for integer, if you remember. So in 2-bit architecture of what is a machine, it had two bytes of size. and in cases where you have 32-bit processor, it has 4 byte of 4 byte of size. So int size was variable in C language, and as well as C++. So it was kind of dependent on the underlying architecture platform. So portable actually defines the data type size as constant across all the platforms. So even if it is Mac machine or Windows machine or Linux machine or 32-bit processor machine or 64-bit or 16-bit, it is still the same size. So that is the portable nature of Java applications, right? So in Java applications, you can rest assured that all the types what you are using are all having a constant size across all platforms, all right? And then comes this nature of dynamic. Java applications are very dynamic in nature. When I say dynamic, I mean to say that many things in application runtime happens at dynamically. So things like memory allocation, unlike C or C++, where you had to allocate memory manually, and where you had to deallocate memory manually, you don't have to take that pain in Java. Memory allocation and deallocation happens automatically. Okay, at the runtime, I mean to say memory. Let me see if I have started the recording. I just hang on. Yeah, I have done it. Okay. So memory allocation and deallocation happens at the runtime. It is dynamic in nature, and then things like object creation. When you create an object, that object is created at the runtime dynamically. Class loading operation, the classes which you load in your applications, that happens dynamically. So Java is very dynamic in nature, and that's why it is one of the important buzzwords. And then Java has robust nature. The applications are very robust. The reason behind that is applications are fail proof, so they are kind of less prone to fail, and even if the application fails, it will not affect the underlying hardware. So the hardware is safe because all the Java applications run on a virtual layer on a VM called as Java Virtual Machine, and that VM is responsible for executing your Java applications, and which makes Java very robust in nature. So the Java applications will not affect the underlying hardware if something goes wrong. All right, and then this distributed nature, Java applications are very distributed. You can create distributed applications. When I say distributed, it means that the applications are kind of deployed on different machines. It might be deployed on more than 10 machines simultaneously. So part of the application is deployed on one server, and part of the application is deployed on another server. When you come to the enterprise part of Java, you will see that the whole application is not deployed on one machine. Rather, you have multiple servers used for deploying your application. So that's what is this nature or distributed nature talks about, that the applications can be highly distributed and they can be spread across different machines to serve your one purpose. Okay, and Java applications are highly secure. They are secure from, I mean, they have good security protocols as well with respect to encryption and with respect to security of the data and all. Apart from that, the application bytecode, the binaries of Java application, that is itself secure, and that is secure from virus as well. It is virus free. All the applications in Java, they are the binary is in bytecode. The bytecode is virus free most of the time. It cannot be affected by virus because the only application which understands your bytecode is your virtual machine. So apart from virtual machine, your bytecode is not understood by the hardware directly, or the platform or the OS directly. So that is the reason all the Java applications are very secure from data theft and things like that, and they are secure from virus as well. All right. And Java, this is one of the star features again, uh, that is multi-threading. Java supports multi-threading like no other language has done earlier to Java. Java has an inbuilt support for multi-threading. All right, and we will discuss this concept of multi-threading in great detail when we come to the concept of threads. All right, and obviously Java is high performance because Java does not utilize the infrastructure resources heavily, unlike C or C++ applications does. So this is very high performing application. So these are some buzzwords what you often hear when you start any textbook in Java. If you see if you open a textbook, you might see these buzzwords. So you have to understand what this actually means. All right. So based on these star features, I can say that people adopted Java, and there was a sudden change and trend in the number of people who started writing applications in Java. So previously, all those developers and programmers who were using C, C++ for doing regular tasks. They also started adopting Java because of this easy in nature and these all benefits what Java has provided. All right. So then we will discuss about the data types which are supported in Java. Java supports these primitive data types. Um, this is standard across all the platforms, and this is not like in C and C++ where you had variable data type size. Like in C, you used to see that an integer can be of 2 byte or 4 byte, but in Java it is standardized, so it is constant for all platforms. It doesn't change. Right? So you have 8 primitive data types in Java. The first one is a byte, which is 8-bit, and then short, which is 2 bytes, that is 16-bit, and then there is an integer which is 4 bytes, and it is 32 bits. It means, and then lastly, it is a long, which has 8 bytes. These four are integer data types. They are used for doing integer kind of operations. Byte is of the shortest range, and long is of the biggest range in numeric data types. And then you have two data types, that is float and double for any decimal values. So this is all the numeric data types. You have 6 numeric data types, and then one character data type, which is of 2 bytes, and one boolean data type, which is boolean. It has only two values, true or false. If you notice that here in Java, character data types takes two bytes as the size, instead, unlike C or C++, where you had 1 byte or 8-bit character. So the difference here is Java uses uh, uh, Unicode standard character set instead of using ASCII value. So it doesn't use ANSI data type, rather it uses Unicode. That's why you have 16-bit as the size. With using Unicode character set, Java can support uh, characters from other languages other than English as well. So you can print statements in Java using traditional languages, Eastern languages like Chinese, Japanese, or Indian languages like Hindi, Tamil, Telugu, etc. So these languages are kind of included in the Unicode character set. So Unicode character set supports languages across the globe. All the languages can be used to display something on the user's front. Okay. So this is one major difference when compared to the other languages. Now the reason I often discuss or compare Java with older languages is it has been seen a trend since when I started programming back in 2005, and that was when people started using Java of late. So that was a trend generally, that people who are coming to learn Java, they have some awareness of C or C++. If you don't have it, it doesn't matter a lot. It doesn't matter at all in this session. But I just often discuss about things which are different when compared to C and C++ in Java. So we have a huge community of students as well as developers who are already aware of C and C++. But if you don't know that, it doesn't matter at all. All right. Apart from that, lastly, in Java, we use the string type for all the strings instead of using character array, unlike in C or C++. So Java has defined a type called string as a library instead of defining as a primitive data type. So these all types are defined as primitive data types, the 8 primitive data types, whereas string is defined as a library. Okay, so we have a class called string in Java, which we will use for all the string related operations. All right. Any questions this far? Yes, guys.
No,
No, that's good.
All right. Let me then continue. And then the operators in Java, if you know these operators, they are pretty much same what you have seen in C or C++. You have arithmetic operators, which means these are for addition, subtraction, multiplication, division, and then modulus operator. And relational operator, which is less than, greater than, less than equal to, greater than equal to, not equals to kind of stuff. And logical operators, which is double ampersand is for and condition, and double pipe is for or condition, and this negation is for not condition. And then logical non short circuit operators, this is also for and, this is in boolean statements, and this is in any character statements. So I'll show you some examples on that. And then you have assignment operator, which is used for assigning a value to a variable. All right. And ternary operator is used for checking conditions like if else conditions, where you have on the left side you have the condition to check, and in the middle you have statement to do if it is true, and then you have statement to do if it is false. All right. Ternary example. And then you have unary operators, which is increment operator, which is simply used to increment any number by 1, and decrement is for reducing the number by 1. And compound operators are combination of assignment as well as arithmetic operation. So this plus equals to indicates that if you say x plus equal to 1, it will say x plus 1 equals to x, kind of x equal to x plus 1. And if you have minus equals to, it will say x minus something, x equal to x minus something, kind of things. Right. And these are very basic operators. I'll give you one or two examples, and then you can continue with this. Shift operators are used for shifting the characters, or I mean to say the boolean values. This is left shift, this is right shift, and this is right shift append 0 operator. And bitwise operators, again, these are all bitwise operators. This is for ANDing bits of a number, and this is compound of that, and this is for OR, this is for negation. Right. And then lastly, comparison operator is used for comparing stuff. This compares left hand side to right hand side, and equals to, if checks if it is equals to, this checks if it is greater than, if this checks if it is greater than or equal to, less than or equal to, and not equals to. All right. They are similar to the relational operators, nothing different. All right. So we will have a look at these operators in one of the examples and see. So let's get started to writing one sample Java application, the traditional conventional hello world application, which is the very first program. So I'll use a notepad for that purpose. So initially for few discussions, as long as we are discussing the syntax and core concepts of Java, initially for a couple of sessions we will use Notepad, because this doesn't give you any code assistance, and this is very primitive way of writing applications. It will not have any spell checker, it will not have any code checker assist things. So if you have a habit of writing programs in Notepad initially for a couple of days, then we will start using some editors in which you have code assist and all. Okay, so yeah, I can say this is as hello world class, hello world application, and this is how I start a class with the first keyword called as class, and the second thing is the name of the class, hello world, and then I start curly brace and end curly brace. In between this goes my class. All right, so here I'll have one method which will be the first method, which is a main method. So the syntax for main method is like this. You have to digest it initially. As long as we don't understand what is public, what is static, what is void, and what is main, you will simply assume this to be the syntax of writing the main method, and that's how it will be. All right. And the main method takes a string array as arguments, right? And this also has one curly brace. So this is one block of code which is a method, main method. So main method starts over here and ends over here. Then class starts over here and end over here. Alright. In between goes your statement. So I'll give a statement called system.out.println hello world. This is Java training session. Alright. So in this print statement, system.out.print line, this statement is used for printing anything in Java, right? And after that, whatever you give inside this brackets and within this quotes, in the quotations, it will treat this as a string, and that will be printed on the console. All right. So this is my first class. Let me now save this. So I will use one folder in my application, in my directory. I'll take users, my user, workspace training. Okay, here I'll create one new folder. All right, this is Java underscore 27 July. Right, I'll remember this batch with this name. So I have just created one directory in which I will save my file. So I'll save this name with the name hello world dot Java. So you save the file with the name hello world dot Java. Alright, and now to run that file you need to have this console. I'll exit this, go to CMD, open a console, and cd workspace training, and over here you have this file called firstprogram.java. Oh, no, in this I have this Java 27 July batch. Yes, sorry, excuse me, hang on. Alright, sorry for the interruption. I kind of caught some cold and sneezes today morning. So bear with me for as long as this is not cured. Alright, so this is where I have saved my Java class. Let me see the contents. I have this hello world.java class. Now to compile your code, you will have to say command called javac. Javac is the compiler which will kind of compile your source file and generate the bytecode. Javac hello world.java and press enter. It takes a while, then it compiles, and that's it. It is done. Check the contents. It will generate this hello world class, and it means that your source code is compiled to bytecode, and this bytecode is now runnable file where you can using which you can see Java functioning. All right, so to run that, I'll simply say Java hello world. This means that I am calling the same class file hello world which I have defined. I'm calling that file, and when I run this, it will print this message. Hello world, this is Java training session. All right. So this is nothing rocket science involved here. This is quite simple. So these are the steps what you have to take care. The first thing, how to execute a Java program. What we have done, we have compiled the source code .java class into bytecode by using Java compiler. All right, you had this. Now where do you get this Java compiler? How do you have this? If you run Java C and you get this thing, it means that you already have Java compiler installed, Java JDK installed. If you do not have this, then the first thing what you will have to do is go and download JDK, install that in your machine, and you will be then able to compile your code. So how do you download JDK? If you want, I can give you steps for that. You have to say JDK 7 download, and it will give you an Oracle site which has this Java JDK available. There you can download it. So yeah, this is where you will be reaching to, and in Oracle you will have you will see Java SE Development Kit 7 downloads, and in this you go down and search for your appropriate operating system. If you have Linux machine, you will choose any of these things. If you have Mac OS, you will go for this installer. If you have Solaris, you will go for this installer. And last but not least, if you have Windows, x86 is for the 32-bit processor. If you do not have latest machine, if you don't have a new system, maybe if it is 4 or 5 years old, then it is highly possible that it is a 32-bit system, 32-bit processor, and then in that case you will go and download this Windows x86. If you are having a new machine, a new lappy maybe, so you might possibly have a 64-bit machine. In that case you will download this Windows 64. So to understand what machine you have to check your system configuration and accordingly choose an appropriate download. So in my machine, I have this X64, that is a 64-bit processor. I'll select this one to download. It will ask you to select the agreement. So you have to accept the license agreement and then go for downloading. I will not download because I already have it installed. So you guys continue doing that. All right. So how many of you already have this Java JDK installed?
Myself.
You have it. This is Sampath, right?
Yes, yes, yeah.
All right. And what about you, Shailaja?
Yeah, I have it. I have it.
You have JDK installed.
But sometimes, yeah, no, I installed it.
Okay.
I installed it, but generally I use Eclipse. I don't know this means to do like this, like on the directly.
That's what we
So
now I have shown you, right, how it works. Now you know it.
yeah. Now it's all.
Now
Yeah,
you
now
know.
it's
Okay,
okay.
good. So we will not use Eclipse
Yeah.
immediately because using Eclipse will
What?
kind of make things simple for you. I know that simplicity is good, but before you going for the simple approach or easy approach, you have to understand the core concepts. Okay, so you will not touch Eclipse as long as I say you to. Is that fine?
Yeah. That's fine. Yeah.
Great. So you will use a notepad
Okay.
and do things like what I'm doing here. And lastly, how about
Okay.
you, Abhishek? Abhishek, you have got JDK installed on your machine? Hello? Did we lose him? All right, no issues. I will connect with him once again if it is required. And all right, let me take the discussion forward. So to execute a Java program in Windows, the steps are: first save your file with .java extension, then run this command called javac hello world app.java, and then java hello world app. Whatever, I have not written app in my example, so this is redundant. So it's up to you. Then one thing you might also want to do when you are using JDK for the first time, if you are using JDK for the first time, you do not, if you do not have the JDK added to the path, then you will have to set a path to the bin folder where you have your JDK, right? That you can do using your system properties, advanced system properties, environment variables. You can simply go and add JDK to your path. All right. There is a variable called path. You have to add JDK here. Okay. That will be one step what you will have to do. If you are not able to understand about this, you ask me. I will definitely explain you what are the steps for setting up the path, or else you can simply go to Mr. Google and ask setting path uh, Java path in Windows. So you will get numerous articles. It's quite easy, right? In fact, you see Windows has Google has given you directly this one. It's way too simple, right? So try to do it yourself. If you're not having if you're not feeling comfortable, ask me, I can guide you, right? Let me move forward. So in Java platform you have different layers which help your application development as well as application runtime environment. You have different layers. So this is the Java platform diagram, the overall Java platform, how it looks when you are looking at an application point of view. So on that bottom layer, you have this system hardware. Hardware might be of any company. It might be Intel or Mac, Apple or whatever. So this is the bottommost layer. On top of that layer, you have operating system. It might be Windows, Unix, Solaris, Macintosh, blah blah blah. So based on these different operating system, again on top of that you will have one Java runtime environment, right? On top of the system operating system, you will have the runtime environment. In runtime environment, you have virtual machine, JVM, and Java libraries, Java API classes. So this together creates the Java runtime environment for you. So Java runtime environment includes two things primarily. You have to understand what are those. One is the virtual machine, JVM, and the other is Java libraries. So when you have things like there is a class called string in Java. So how do you get this string class in your application? That is by the availability of Java API classes or runtime libraries, I call it as. And then there is a class called system, in which you have an object called out, on which you are calling a method called print. So how do you get this available? Again, the same thing. You have Java API classes, Java runtime libraries available, using which you will be able to call those things. All right. So the platform is inclusive of these two major components, Java libraries and JVM. All right. Then we will understand what JVM is, what the use of JVM is, and what it is serving the purpose, and etc. All right. So JVM is the virtual machine which is responsible for application running the applications in Java. So without JVM, your Java applications will not function. All right. So JVM is the layer. It is the layer which acts as the interface between your Java application and the operating system. If you do not have JVM, the operating system will not have capability to understand what Java code is. Okay? So by default, your operating system does not have the interpretation of your code. JVM understands it and it executes it. All right. So I have segregated the responsibilities of JVM into different blocks here. One is class loader, one is bytecode verifier, interpreter, etc. etc. So I'll talk about this. All right. So when your JVM starts, when your application starts, it has to load classes from different locations. One is your class, which is this hello world. It has to load this class. Right? And then it has to load this string class, which is available in uh, libraries, Java libraries. It has to load this system class, which is also available in libraries. Right? So it has to load classes from different locations. For that purpose, it has one important role to play, that is of loading classes. So JVM has few class loaders where it will load the classes from and get your classes into the execution engine, and that is when your application can execute. All right, that is one role. The other role is to verify the bytecode. So if you know that the bytecode is generated by Java compiler. When you say Java C hello world or Java, that is when your source code is converted to bytecode, and this bytecode now will have to be verified before it is loaded in your execution engine. The reason for verifying is, imagine that if someone tries to tamper your bytecode. So if that happens, bytecode verifier will actually prevent the bytecode to be loaded in execution engine, and the application won't function. So that is why Java applications are tamper proof as well. You cannot tamper the bytecode and modify something and maybe truncate something and try to load that in your execution environment. So this will prevent it, will stop. So this part of JVM is responsible for verifying the bytecode, whether it is generated from a authentic valid Java compiler or not. Right, that is one responsibility. And then this is before loading or before executing your application, it has two responsibilities. One is class loading and one is bytecode verifying. And secondly, the execution engine comes into picture, where it actually executes your application. It executes the code. So the important functionality for JVM here is JVM interpreter. It interprets your code and gives you the output. All right. So the term interpreter, if you understand what the difference between interpreter and executor is, execution and interpretation are kind of different. The difference you can understand that is interpretation is a kind of sequential step-by-step execution of a code whereas execution is one-time execution of all the binaries. So C, C++ applications are all executed. They are executables. You have binary native code created, and when you run that, you will see that the application generates the output. So those are executables. Whereas interpreter is kind of sequential, and it does line by line maybe. Okay. So technically speaking, interpretation is kind of slower when compared to execution, but it provides a lot of other benefits when compared to the executables. All right. So that is why it is favorable. And then the next application or next role of JVM is to manage threads. There is a program called Thread Manager which manages all the threads. Now, the responsibility of this thread manager is to manage multiple threads running for within an application. So as I told you earlier that Java has inherent support for multi-threading. This is what I meant, that JVM has its own thread manager. Now this thread manager will be useful when in cases where your operating system doesn't support multi-threading. There might be cases we had earlier, we had uni-threaded operating systems, right? Primitive age I'm talking about, maybe 90s, early 90s or maybe late 80s. We had lot of operating systems which were uni-threaded. In that kind of scenario as well, if you have a uni-threaded operating system as well, JVM has got its own thread manager, and with the help of this thread manager, your Java applications can still have multi-threaded functionality even if your operating system doesn't support multi-threading. Alright, this is one good feature in JVM. And then garbage collector, this is again one important responsibility of JVM. It kind of deallocates all the memory which is not used by the application at any time. So at any time, if the application sees that there are unused portion of memory in the heap area, um, if there are unused objects, garbage collector will mark and sweep all those objects, and it will clean up the memory for you. All right. So with this feature of garbage collection, the Java developer will not have to bother about memory deallocation every time he writes code. Okay. So this feature helps you to clean up your memory resources often as and when this garbage collector runs. All right. And then comes this memory manager. This memory manager is the application which takes care of different areas of memory like stack area, heap area, and method and register and all. So there are cases where your memory, these are different areas what Java application uses for storing memory, storing stuff in memory. Like for references or variables, it will use the stack, and for objects and runtime related objects and all, it will use heap area. Again, this method area is part of the heap area as well, and register is part of the stack area. So all these memory related responsibilities are taken care by this part of JVM. And last but not the least, we have this JIT compiler. We call it as JIT compiler, which is kind of again a feature which makes the application performance faster. So JIT compiler will actually at the runtime it tries to make the bytecode translate to a further layer, and it converts that to native code to make things faster. All right. So imagine that the Java application, if it is hosted on a server, and there are portions of memory which is heavily used. There are portions of Java application code which is heavily used, and that needs to be interpreted very often. So that interpretation is kind of a slower process, as I told you earlier. So to make interpretation faster, there are cases where Java JVM converts some amount of code to native by using JIT compiler. All right. So that will actually make the execution faster, because once it is converted to native code, it might be part of your Mac machine or Windows machine or whatever, but this code will be much faster when compared to the normal interpreted code. So this, now again, what is JIT compiled is not, it is not in developers responsibility. It will be the responsibility of JVM to decide which portion of code it has to JIT compile. All right, and that is how it kind of improves the performance. All right, so I'll give a pause for a moment here, and I'll take questions from you if you have any.
No, go ahead.
Mm,
Any questions?
So stack area and heap area, all those things are, I did not get it clearly. Maybe I think we'll learn later, right?
Memory, I mean, though it is not very much detailed, we discussed even in future sessions, but I'll give you some idea. When we come to objects and all, we will have, we will touch this stack and heap once again, but I can give you
Oh,
some information. In stack, if you declare a variable, like for instance, if you say, here, if you say int I equals to 10, all right, so these kind of references or these kind of um, um, uh, declarations are stored in stack. So all the primitive declarations, let it be int or if it is char, uh, these things go inside the stack area. All right. Then you
okay.
might have things like I'll go for a custom defined object called as person p equals to new person. All right, let's assume that I have a class called person and I'm creating an object of that. So the reference of this object is person p, right? This is the
Yeah.
declaration, this is the declaration, and this is the initialization. So this declaration stuff, the reference will go as part of stack p. P will be part of stack, right? Whereas the object which is created, the actual object, will be part of heap, the person object. So I'm drawing this as an object just to make it clear. So now these data types or these declarations know the size of the data, right? For int it will take
Yeah.
4 bytes, for char it will take 2 bytes. But for objects it doesn't know what will be the size of the object, because the object size can grow dynamically, right? For that kind of
Okay.
dynamically allocated heap areas is used. Right, so we will again visit this topic once we are discussing objects and stuff, so that in that discussion also you will get some more idea about this, right? But this should
Okay.
be some good idea.
Yes.
All right, any more questions? So you got to keep the session lively. It should not be a monotonous session. That will cause me lose interest. The more questions you ask, the more interactive the session will be. All right. So try to make some notes of the points which I discussed during a session, and you can simply ask a question randomly. Now, the question if you are asking need not be a very difficult or complex or rocket science knowledge question. You can ask as simple question as possible. I mean, it can be a very layman's question as well. It's not wrong in asking questions. All right. In fact, it is good. I remember a quote what I read today from the former president who passed away yesterday night, Dr. APJ Abdul Kalam. So I read one of his quote today. He was highly in discussion across all the social networking platforms. So one quote which I read is about students. He was encouraging the students to ask questions. I mean, students' duty is to learn. So the more you ask questions, the more you learn. So try to make this as a habit and make the sessions lively. All right. All right. Silence is acceptance, I think. All right. So let me take a couple of examples based on the data types what we have discussed for the day, and based on that again we will take one or two examples based on the operators, and then we can wind up the session. So all right. So the data types what we have seen, the way we declare in int I equals to, I mean I just declare this step is called as declaration, and I equals to 10 is initialization, and if you want to do that in maybe one step, you can say int j equals to 20. This is done in one step. You are doing initialization and declaration in one step. So that's how you declare a variable, and you initialize a variable. And if you want to do it in one step, you can do it like this. All right. Now I will take uh, examples based on the operators. So I'll say I plus j. So this is the concatenation operator. This is a string which I am defining, and this is the concatenation operator. And over here I'll separate uh, I plus j. All right. Then I'll say I minus j, I minus j, I multiplied by j, I divide by j. All right, and I'll say I mod j. This will give me the modulus of the value. All right. So I'll take I as 10 and j as 2. All right. So now let me Java C operators.java. It is compiled, and then I'll say Java operators, run this. Then I'm getting this stuff. It says I plus j equals to 10 plus 2, 12, I minus j equals to 8, I into j equals to 20, and I divided by j equals to 5, I mod j equals to 0, because when you divide 10 by 2, you don't get any reminder. That's what modulus operator is for. All right. So this is for you. Go ahead, try these examples, maybe one or two examples what I have done. Try to make your hands comfortable. Try to write some examples in this fashion. And again, when you start the session tomorrow, we'll start with questions if you have any, then we'll continue for the next topic. Before I conclude, if you have any questions?
Still, yeah, here in the, I mean, the output line, the system out println line, you give I plus j, then again plus I plus j in a bracket.
Okay, so
Is that mandatory to give that?
this is this I am giving to separate this string from uh, this value. So if I give things in bracket, this will take as one computation. This will compute things inside the bracket will get compute, and then that will be appended to the string. Because if you see, can you just mute your line, Sampath, right?
Yeah.
So just mute your line. You can unmute and talk when you have to. So this print statement, when you have this print method called, you will give one string. So this is a string, and this is a concatenation operator which is used for combining two. If you do not give this braces here, okay, let me remove the braces and then show you how it behaves. Compile, then run. There you see. So it is taking 10 and adding this 2 as a string. It is considering this 2 as another string and making this I also as a string, and it will become 102. Okay, so to avoid that, we will use the braces. We will have some of this discussion again when we come to strings. Okay, when we will discuss strings in Java, we will discuss as to why to separate these things and all. Okay, but for now I can explain it in this way. If you do not provide these braces, it will treat this as one string, this as one string. All right.
So can you write without that, like just the I plus j, then close the bracket, no need of writing the second string?
So if you see
Does it
the
work?
output, what I got here is 102, but whereas 10 plus
Yeah.
2 will be 102, right?
What I'm saying,
No,
yeah.
10 plus 2
What I'm
will
asking
be
is
12,
just
right?
write print out such.
Sorry,
Mm-hmm.
10 plus 2 is 12 or
What I'm asking
102?
is if you write, it's 12, right? No, my question is, if you write just system.println, then bracket, colon, I plus j, then close, is that fine, or we need to add the continuation thing too?
If you say this, you want me to remove this?
Yeah.
This is also fine. What's wrong? I mean, um, you will not see this I plus j string printed. The difference is you will not see this one.
Oh, alright. Now I got it.
So I just wanted to give you a print statement. You are seeing I minus j,
Got
I
it.
into
So,
j. This is one print. That's it.
oh, alright. Yeah, now I got it. So, which you give in the brackets, I mean, the columns will
So
show
when
it
I
in the.
say I plus j in string, it will print it as
Mm-hmm.
it is.
Alright.
This
Okay.
will be printed as a
I
string.
thought that will be the answer.
This will be printed as a
Oh,
string, and this will be computed.
alright. Got it.
Right?
Thanks.
All right. Good. Fine then. So that is all for the day. We will again continue tomorrow.
Okay, bye. Thank you.
Thank you for joining.
Okay, thank you.
Have a good
Yeah,
day.
thank you.
Yeah, sure.
Yeah,
Have a good
thank
day.
you.
Bye
Good,
bye.
good night.
Yeah. Bye.
Same to you.